When working with fasteners and electrical lugs, applying the correct torque is critical for ensuring a secure and reliable connection. Insufficient torque can lead to loosening, overheating, and even failure of the connection. Excessive torque can damage the fastener or lug, compromising its integrity. Several resources provide torque tables for both standard fasteners and Ilsco lugs. For standard fasteners, the American Fastener Standards Institute, or AFSI, offers standards and information. The Industrial Fasteners Institute, or FE, is another excellent resource for technical information on fasteners. Fastenal also provides torque charts that can be helpful. When it comes to Ilsco lugs, Ilsco provides their own torque tables. Additionally, Panduit offers torque tables for their lugs as well. To find the appropriate torque value for specific application, it's essential to consult these tables. For example, a 600 MCM conductor with a 3/8-inch Ilsco lug requires a torque of 250 foot-pounds. A 1000 MCM conductor with a 1/2-inch Ilsco lug requires a torque of 400 foot-pounds. And a 1200 MCM conductor with a 9/16-inch Ilsco lug requires a torque of 525 foot-pounds. These values are specific examples, and the correct torque will vary depending on the lug size and conductor size. Always refer to the manufacturer's specifications for the specific product and application you are working with. Torque values can differ based on factors such as the material of the fastener or lug, its size, and the thread type. Using a calibrated torque wrench is highly recommended to ensure accurate torque application. A torque wrench allows you to apply the correct amount of force to the fastener, preventing over-tightening or under-tightening. Before using a torque wrench, make sure it is properly calibrated and set to the desired torque value. It's also important to follow the manufacturer's instructions for using the torque wrench. When tightening fasteners or lugs, apply the torque gradually and evenly. Avoid jerking or sudden movements, as this can lead to inaccurate torque application. If you are working with multiple fasteners, tighten them in a saw pattern to ensure even distribution of force. This helps prevent distortion of the connected component. In addition to using torque tables and a torque wrench, it's also important to inspect the fasteners and lugs for any signs of damage or corrosion before installation. Damaged or corroded fasteners can compromise the integrity of the connection and should be replaced. Also, make sure that the mating surfaces of the fastener and lug are clean and free of debris. Dirt or debris can interfere with the proper seating of the fastener and affect the torque value. When working with electrical connections, it's crucial to follow all applicable safety precautions. Always de-energize the circuit before working on any electrical components. Wear appropriate personal protective equipment such as gloves and eye protection. If you are not comfortable working with electricity, consult a qualified electrician. Proper torque is not just about tightening a bolt or lug. It's about creating a reliable, long-lasting connection that can withstand the stresses and strains of its environment. By following the manufacturer's recommendations and using the correct tools and techniques, you can ensure that your connections are properly torqued and will perform as intended. In summary, firstly, consult torque tables from reputable sources like AFSI, IFI, Ilsco, and Panduit. Secondly, always refer to the manufacturer's specifications for the specific product and application. Thirdly, use a calibrated torque wrench to ensure accurate torque application. Fourthly, apply torque gradually and evenly, and use the star pattern when tightening multiple fasteners. Fifthly, inspect fasteners and lugs for damage or corrosion before installation. Sixthly, ensure mating surfaces are clean and free of debris. Seventhly, follow all applicable safety precautions when working with electrical connections. By adhering to these guidelines, you can ensure that your fasteners and lugs are properly torqued, resulting in a safe and reliable connection. Remember that electrical work can be dangerous, and it is always best to consult a qualified electrician if you are not comfortable performing the task yourself. Properly torqued connections are essential for the safe and efficient operation of electrical systems. In addition to the points mentioned earlier, consider these additional aspects of torque and fastener selection. Firstly, understand the materials involved. The material of the fastener and the material of the components being joined can significantly impact the required torque. For example, softer materials like aluminum may require lower torque values than harder materials like steel. Secondly, consider the environment. The environment in which the fastener will be used can also affect the torque requirements. For example, fasteners exposed to corrosive environments may require higher torque values to ensure a tight seal and prevent corrosion. Thirdly, pay attention to thread lubrication. Lubricating the threads of a fastener can reduce friction and allow for more accurate torque application. However, it's important to use the correct type of lubricant and to adjust the torque value accordingly. The manufacturer's specifications will typically indicate whether lubrication is required and what type of lubricant to use. Fourthly, consider the fastener type. Different types of fasteners, such as bolts, screws, and studs, may have different torque requirements. Be sure to consult the appropriate torque table for the specific type of fastener you are using. Fifthly, inspect the threads. Before installing a fastener, inspect the threads for any damage or debris. Damaged threads can prevent the fastener from properly seating and can affect the torque value. Clean the threads if necessary. Sixthly, use the correct size tool. Using the correct size wrench or socket is essential for applying the correct torque. Using a tool that is too large or too small can damage the fastener or the components being joined. Seventhly, avoid over-tightening. Over-tightening a fastener can damage the threads, strip the fastener, or even break the fastener. It's always better to err on the side of under-tightening than over-tightening. Eighthly, retorque when necessary. In some applications, it may be necessary to retorque fasteners after a period of time. This is because the fastener may loosen due to vibration, thermal expansion, or other factors. The manufacturer's specifications will typically indicate whether retorquing is required and when it should be done. Ninthly, keep records. Maintaining records of torque values in fastener installations can be helpful for future maintenance and troubleshooting. These records can also be useful for demonstrating compliance with industry standards and regulations. Tenthly, seek professional guidance. If you are unsure about the correct torque value or fastener selection for a particular application, consult a qualified engineer or fastener specialist. They can provide guidance and ensure that the fastener is properly installed. Proper torque is not just a matter of tightening a bolt or lug. It's a critical aspect of ensuring the safety, reliability, and performance of mechanical and electrical systems. By understanding the factors that affect torque and following best practices for fastener installation, you can help prevent costly failures and ensure the long-term integrity of your equipment. Remember that the information provided here is for general guidance only and should not be substituted for the manufacturer's specifications or the advice of a qualified professional. Always consult the appropriate resources and take the necessary precautions when working with fasteners and electrical connections. Furthermore, understanding the units of torque is crucial. Torque is typically measured in foot-pounds or Newton meters. A foot-pound is the amount of torque required to apply 1 pound of force at a distance of 1 foot from the axis of rotation. A Newton meter is the amount of torque required to apply 1 newton of force at a distance of 1 meter from the axis of rotation. It is important to use the correct units when setting a torque wrench. Many torque wrenches have both foot-pound and Newton meter scales. Be sure to select the correct scale for the desired torque value. When converting between foot-pounds and Newton meters, use the following conversion factor: 1 foot-pound equals 1.356 Newton meters. For example, a torque value of 250 foot-pounds is equal to 339 Newton meters. Also, understanding the different types of torque wrenches is important. There are several types of torque wrenches available, each with its own advantages and disadvantages. Some common types of torque wrenches include clicker torque wrenches, beam torque wrenches, and electronic torque wrenches. Clicker torque wrenches are the most common type of torque wrench. They are easy to use and provide an audible click when the desired torque value is reached. Beam torque wrenches are more accurate than clicker torque wrenches, but they are also more difficult to use. Electronic torque wrenches are the most accurate type of torque wrench. They provide a digital readout of the torque value and can be programmed to alert the user when the desired torque value is reached. When selecting a torque wrench, consider the size of the fasteners you will be working with and the range of torque values you will need. It is also important to choose a torque wrench that is comfortable to use and easy to read. Proper maintenance of torque wrenches is essential for ensuring their accuracy and longevity. Torque wrenches should be calibrated regularly, typically every 6 to 12 months. Calibration involves comparing the torque wrench's readings to a known standard and adjusting the wrench if necessary. Torque wrenches should also be stored in a clean, dry place to prevent corrosion and damage. Avoid dropping or mishandling torque wrenches, as this can affect their accuracy. Additionally, when working with electrical lugs, consider the following factors specific to electrical connections. Firstly, ensure proper surface preparation. Clean the conductor and lug surfaces to remove any oxidation or contamination. Use a wire brush or abrasive pad to remove any loose material. Apply an anti-oxidation compound to the conductor and lug surfaces to prevent future corrosion. Secondly, select the correct lug size. Choose a lug that is properly sized for the conductor. The lug should fit snugly over the conductor and provide adequate surface area for the connection. Thirdly, use the correct crimping tool. Use a crimping tool that is designed for the specific type and size of lug you are using. Follow the manufacturer's instructions for crimping the lug to the conductor. Fourthly, inspect the crimp. After crimping the lug, inspect the crimp to ensure that it is properly formed. The crimp should be tight and secure, and there should be no gaps or voids. Fifthly, torque the connection. Torque the lug to the manufacturer's specified torque value. Use a calibrated torque wrench to ensure accurate torque application. By following these guidelines, you can ensure that your electrical connections are properly torqued and will provide a reliable, long-lasting connection. Remember that electrical work can be dangerous, and it is always best to consult a qualified electrician if you are not comfortable performing the task yourself. The NEC, or National Electrical Code, provides guidance on the proper installation and torquing of electrical connections. NEC Section 110.14 B covers the tightness of connections. It states that all electrical connections shall be torqued to the manufacturer's specifications. If the manufacturer's specifications are not available, the connection shall be torqued to the values specified in NEC Table 110.28. However, Table 110.28 does not exist. The correct table to refer to is NEC Table 310.16 for allowable ampacities of insulated conductors rated up to and including 2000 volts. It's essential to consult the latest edition of the NEC for the most up-to-date requirements. Furthermore, consider the impact of temperature on torque values. Temperature variations can affect the torque of fasteners and lugs. As temperature increases, the metal expands, which can reduce the clamping force of the fastener. Conversely, as temperature decreases, the metal contracts, which can increase the clamping force. In applications where temperature variations are significant, it may be necessary to adjust the torque value accordingly. Some manufacturers provide temperature compensation charts that can be used to adjust the torque value based on the operating temperature. Also, consider the effects of vibration on torque. Vibration can cause fasteners and lugs to loosen over time. In applications where vibration is a concern, it may be necessary to use locking fasteners or other methods to prevent loosening. Locking fasteners are designed to resist loosening due to vibration. Some common types of locking fasteners include lock washers, lock nuts, and thread locking compounds. Lock washers are placed under the head of the fastener and provide a spring force that helps to maintain the clamping force. Lock nuts have a locking mechanism built into the nut that prevents it from loosening. Thread locking compounds are applied to the threads of the fastener and create a bond that resists loosening. In addition to using locking fasteners, it is also important to ensure that the fasteners are properly torqued. Properly torqued fasteners are less likely to loosen due to vibration. Moreover, consider the use of strain relief. Strain relief is used to protect electrical connections from stress and strain. Strain relief devices can be used to support the weight of the conductors and prevent them from pulling on the connection. This can help to prevent loosening and damage to the connection. Strain relief devices are available in a variety of sizes and styles. Choose a strain relief device that is appropriate for the size and type of conductor you are using. Additionally, consider the importance of documentation. Proper documentation of torque values and fastener installations is essential for maintaining the integrity of electrical and mechanical systems. Documentation should include the date of installation, the torque value, the type of fastener, and the location of the fastener. This information can be used for future maintenance and troubleshooting. Documentation can also be used to demonstrate compliance with industry standards and regulations. In summary, always consult the manufacturer's specifications, use calibrated tools, apply the correct torque, consider environmental factors, use locking fasteners when necessary, provide strain relief, and document your work. By following these best practices, you can ensure that your fasteners and lugs are properly installed and will provide a safe and reliable connection for years to come. Remember to consult with qualified professionals when needed and prioritize safety in all your work. Electrical and mechanical systems rely on properly installed fasteners and lugs, and your diligence ensures their integrity.